Hi all, good evening. Today I am gonna to take the topic August Weismann's germplasm theory. Weismann's germplasm theory. The German biologist August Weismann advanced the germplasm theory, or the theory is also known as continuity of germplasm, which is to explain the mechanism of heredity in evolution. He published the theory in 1892 is his book Das Gameplasm. The theory holds that continuity of germplasm is the physical basis of heredity. Heritable variations have their origin in germ cells, and new type of cells and organism arise only from modified type of germ cells. Thus, germplasm theory rejects the Lamarckian concept of the inheritance of acquired characters. Major postulates of germplasm theory. Germplasm theory encompasses three basic postulates as follows. First one, the continuity of germplasm is the physical basis of heredity and it is responsible for inheritance and evolutionary changes. Second, all heritable variation have their origin in germ cells. Third, new type of cells and new forms of life arise from alternation in germ cells. Then basic assumptions of germplasm theory. Germplasm theory is built upon some basic assumptions which can be summarized as follows. The body material of living organisms consists of somatoplasm and germplasm. Somatoplasm is contained in ordinary non-sexual body cells, that is called somatic cells, and germplasm in reproductive sex cells called germ cells or gametes. Germ cells can produce somatoplasm, but somatoplasm cannot produce germplasm. Germplasm is a hereditary material and it will not affected by the factors and changes in the internal or external environment. On the other hand, somatoplasm has no role in heredity and it will affected by external and internal environmental factors and changes. Germplasm is self-perpetuating and it continues to exist through successive generations. On the other hand, somatic cells and somatoplasm perish with the death of organisms. Germplasm can be transmitted from one generation to the next in an sexual reproduction. So it can continue to exist infinitely. In other, there is continuous stream of germplasm through countless generation. That is continuity of germplasm. Somatoplasm is not heritable and it perishes with the death of organism. Thus, it has no continuity through successive generations. Changes in germplasm are heritable while those in somatoplasm are non-heritable. So, germinal changes are continuous and long-lasting or permanent continuity of germplasm. But somatic changes are transitory. Inborn characters are germplasmic and are heritable, whereas acquired characters are somatoplasmic and hence are not heritable. Changes in germplasm may lead to variation, speciation, and evolution. Inborn characters are germinal and hence heritable, but acquired characters are somatic and non-heritable. Germplasmic changes may lead to heritable variation, speciation, and evolution, but somatoplasmic changes have no role in heritable variation, speciation, and evolution. Cardinal concept of germplasm theory. Germplasm theory upholds four cardinal concepts which form its sum and substance. They are: first one, the concept of somatoplasm and germplasm; second, the concept of continuity or immortality of germplasm; third, the concept of germplasmic determinants; and last one, the concept of parallel induction. So, first one, the concept of somatoplasm and germplasm. The body material of an organism is of two kinds, that is germplasm and somatoplasm. Germplasm is protoplasm of germ cells such as sperm and ova. Somatoplasm is protoplasm of somatic cells or ordinary non-sexual body cell. Somatoplasm has no role in heredity, but germplasm is thought to be the actual vehicle of heredity and it is not affected by any influence either from within the body or from the external environment. Germplasm can produce somatoplasm, but somatoplasm cannot produce germplasm. Second, continuity of germplasm. During reproduction, germplasm is contributed by both parents through male and female gametes. These gametes fuse in pairs and form zygote, which receive paternal and maternal germplasm. Each zygote then divides repeatedly. The resulting daughter cell receive equal share of germplasm. Some of these cells differentiate to somatic cell and form the body, that is called soma, of the daughter organism. The other differentiate to germinal cells for sexual reproduction. Somatic cells have no role in subsequent generation since they perish with the death of bearer organism. But germ cells have a significant role because their germplasm will be transferred to the next generation through gametes. Thus, there is a continuous stream of germplasm from generation to generation to which the somatic cell contribute nothing. Germplasm is therefore immortal in the sense that it is infinitely continuous from generation to generation through meiotic cell division. Somatoplasm, on the other hand, is mortal since it perishes with the death of organisms. Third one, germplasmic determinant, or always called nature of germplasm. In 1904, Weismann proposed that every distinct part of an organism is represented in the sex cell by a specific particle that is known as idioplasm or determinant. In each determinant is supposed to be made up of still smaller unit that is called biophores. The sum total of the determinants represent the different part of the adult organisms. The entire determinant would be passed on from one generation to the next, and this would account for the heredity transmission of characters. According to Weismann, these determinants are localized in chromosomes. During the cleavage of zygote, various determinants get segregated, distributed, and localized in different blastomeres. Thus, each blastomere may contain only one kind of determinant and it would develop or differentiate only in a specific way as specified by the determinant present in it. Fourth one, parallel induction. In contrast to Lamarckian inheritance of characters, Weismann introduced the concept of parallel induction. According to this concept, as internal stimulus affects simultaneously both the germplasm and the body or soma. Its effects on germ cell result in heritable variations. This stimulus is believed to be nourishment required for the determinants and biophores. Biophores are living units. So, those determinants which obtain better nourishment are fast growing and stronger than those getting less nourishment. Thus, determinants tend to produce stronger or weaker part of organs in an organism. Weismann assumed the struggle for existence between the better nourished and the lesser nourished determinant as the cause for the appearance and disappearance of variations. Significance of germplasm theory provides the ground for the understanding of concept of Mendelian particulate inheritance. Gives some clue about genes or determinants which reside in chromosomes. The concept of continuity and immortality of germplasm indicates genetic continuity, or the continuity of chromosomes and DNA from one generation to the next. Demerits of germplasm theory. Weismann theory lacks experimental support. The existence of determinants and their segregation during cleavage have not been experimentally proved. Also, the theory failed to explain the causes and mechanism of regeneration and asexual reproduction, which do not involve in any role of germplasm. That's all about my topic. Thank you.